Hi friends, in this series we are deploying machine learning models to different services from GCP, AWS and Azure. App Engine is another serverless framework from Google Cloud. Unlike cloud functions, which are short-lived, which mostly used as microservices in response to some trigger like message, notification, or some change in a database record. Using App Engine, we can deploy more complex monolithic applications, which might run for very longer time or might involve more complex operations. Okay, so by default, App Engine is disabled. So first go to settings and enable your application. So by default, since I have already done, it shows me only disable. But if you are using it the first time, enable your application. Okay, so let's go to the code. So as we saw in our previous videos, we have a machine learning model here, which is already trained, and we have the deploy function, deploy code, which is a Python function using fast API. Okay, so here we have created a predict post method, which takes the features of iris flower and it predict the species, right? So we already went through this code in very detail in one of my previous videos. All right, and then we have the requirement file with the Python libraries. So the only thing new is we need to create this YAML file to deploy an application to Google Cloud App Engine. Okay, so here we are using mostly the important parameters required, but as I said, App Engine, it can run more complex applications, so you can configure sorry. So the only thing new is we need to create this app.yaml file with our App Engine configurations, endpoints, runtimes, etc. Okay, so here we are giving a name to our service, MyML app2, and runtime, this Python 3.9, and our entry point, we are deploying this fast API application using GUnicorn, and then here we have our file name, which is this deploy, and our app name app. So this should match, this deploy :app should match with our deploy function name, which is this deploy and app. Okay, and then what instance we want to run this application on, right? So these four parameters are sufficient to deploy our application. But in a real world scenario, we might configure lots of other parameters like auto scaling, the minimum maximum instances, CPU throughput utilization, so that when and how we want to scale our application and provision more resources, and also for the instance, what type of CPU, memory, etc. We would like to have. Okay, so once we have created this YAML file, deploying is super easy. So we just run this gcloud app deploy.yaml. So I go here. All right, so it will provide the information it is using. For example, the project name, from where it is taking the source code, and the endpoint URL name, etc. So if you are okay, go ahead. It will take a couple of minutes and we'll just deploy the application. Okay, all right. So I have already deployed it. So if I go to services, so this is my ML app. I have deployed 3 versions of this app. Now I can go here. So our default route, simply print this message. And since it is a fast API application, I can access the docs. So let me just go to predict and try it out. Here we have input feature values and simply do the execute. It shouldn't be taking this long, but here is our response. Okay. Now, just to make sure, we can invoke this from config view. Does it show the URL? No. Yeah. All right. So we'll take the endpoint URL and test it from using request library. So our app is deployed to this endpoint, right? So let's take, and here I have a simple script to test our app. So let me create use our new endpoint, and I need to add this predict. All right. So we have the payload headers, and we are just invoking this using the post method with our feature values. All right. So let me run this. It should not be taking this long, but anyway, we can see the results here. So we can see the species name as well as the probabilities for the 3 classes. Okay. It's that easy to deploy to App Engine, right? So as I mentioned, we just need to create this YAML file with the minimum required parameters so that we can deploy. That's all for this video. Thank you very much.